Hello everyone, today we will talk about chapter 10.6, Polar Coordinate System. Polar Coordinate System. In this chapter, in the last session, we mainly learn about the rectangular coordinate system, right? That is about the x and y, the rectangular coordinate system. Rectangular coordinate system tells us that we can define one object's position by using x and y coordinates. But in fact, in mathematics, or in reality, we have another coordinate system to define someone's positions. One of them is the polar coordinate system. Polar coordinate system. What is a polar coordinate system? Maybe some of you may have watched some movie or anime and have heard about the radar system. Radar system. In Chinese, it's called 雷达. Radar system. And in radar system, it is just the picture is just like this. And some of you may have a look on your book on page 52. Page 52. You can see a radar. It's just this one. Oh, someone is scanned. The observer is here and then scan the whole part of the map, and maybe he can define someone here, or here, right? Okay. So let me introduce the polar coordinate system. Again, we have an observation point here, and in rectangular system we know that this one is origin, but in polar coordinate system this one is called the pole. This one is called the pole. And for some target, for example, the target is now here, and let the point be P. And in rectangular system, we know that we use the rectangular, and then we find the x and then y, right? But now we do not use this one because it's very, in fact, in reality, to go to point P, we seldom go in this way and then this way, right? We seldom do this. We usually go in a straight line that is from here to here, right? So this one, in fact, is the distance between O and P, right? The shortest distance also. And for example, I define this one, I let it be 3 cm. This time 3 cm. When I tell you, oh, the point P is 3 cm away us, in fact, you may not, you cannot know the true position of P. Why? Because 3 cm away us, there are many points that satisfy this condition. For example, maybe here, maybe here, maybe here, maybe here. There are many points. In fact, the points altogether is form a circle, such that all the points here is 3 cm away from the point O, right? Because all the radius in the circles have the same distance, right? So, in fact, just telling the distance between the target and us cannot tell the position of the target. So we need one more condition to ensure the target position. That is the angle. That is the angle. So for polar coordinate system, usually we have we draw one more horizontal line here, horizontal line. For this horizontal line, for example, I let this point be x. For this OX, we have a term called polar axis. Polar axis. In rectangular system, we have learned x-axis and y-axis, right? In polar coordinate system, this one, the horizontal one, is polar axis. We do not have this one. We do not have this one. Okay, we do not have a vertical one. Okay, so this one is polar axis. Then the angle for this line, for this point P, is calculated starting from this polar axis and then anti-clockwise to this line, anti-clockwise. So the angle, in fact, is this one. This one. For example, I let this one to be 45 degrees. Okay. Then we can tell the point P, the polar coordinate, is 3 cm away us, and then the angle is 45 degrees. Okay. This one is the polar coordinate of P. Okay, polar coordinate of P. Okay, it's 3 cm away us and 45 degrees starting from the polar axis. And in fact, as this angle, I may tell you, some of you can memorize as using this imagination. That is the sun, okay, the sun rise from the east, right? The sun rise from east. So the starting point is here. That is, this one is 0 degree, and then the sun rise from here to here, right? In the noon, the sun will be here, right? So the angle must be going anti-clockwise, okay? So in the noon, we know that the angle becomes 90 degree, right? 90 degree, right? And then when you go to the west, that is at the night time, so this one will be 180 degree. I may say in the evening, okay? And then go more, and then here will become 270 degree, and then go back. And that means 0 degree is also equal to 360 degrees, right? So there is the whole picture of the polar coordinate system. That is the distance and the angle, okay? The distance and the angle. So, for more information about the name, you may look at page 52. So remember, we write down the polar coordinates of P. We must write down in this way. Don't just write down a bracket and then 345 degree. No, we should write down the whole sentence. The polar coordinate of P is equal to, and then bracket. Remember, use the equal. Don't use the colon, or don't use this. Okay, don't use this one. Use equal sign. Is equal to bracket 3,45 degree. Okay, that is the format of polar coordinate. Okay, then I will tell you how to do the exercise in the next video. Okay.